Welcome to the second in the series of architecting a very smart thermal controller. In this one, we're going to focus on the controller. In the logical architecture, the pieces we're going to be focusing on in this segment, the REST API, the actual thermal controller, and the various sensors and data loggers. In the design considerations, this needs to be simple as absolutely possible. There's no set schedule for the use. The building is very infrequently used, and we need to have remote access by mobile devices. We also need to make things as efficient as possible. We only want to heat the building when it's occupied. We want the preheat time to be the minimum that we can achieve. I don't want to waste any fuel that's just sitting there heating and unoccupied. To get the most efficiency, we need to calculate what's the thermal rise time. This is not artificially intelligent. It is just a simple mathematical regression of the data that we've collected to see how long does it take for the temperature to rise. The overall flow that we're going to use is actually a crude state machine. It will enter into the setup. It will be checking to see if it should be considering to turn on. If it's in the correct time zone that we've calculated based upon the thermal rise, we'll enter the preheat phase. Once we've achieved the expected time for the occupants to arrive, we go into a hold temperature. We check the timer and we check for motion. Should there be no motion and the timer is expired, we shut the thermostat, or we shut the heater off. To do this, we have a data type called a thermal event. A thermal event contains the date and time the building needs to come to temperature and the value for the motion timeout in minutes. For the full list of hardware, consult the GitHub. Basically, it's a Raspberry Pi Zero is used for testing, and a Raspberry 3 is used for the actual thermal controller. We attach a PRI motion sensor so we detect infrared, and we use a temperature sensor. The setup is almost identical to what we did in step 1. However, we're going to use Raspbian Buster, and everything else is almost identical. The API will have the following gets and puts. So we need to get the time to temperature. We need to get the thermal events. We need to get the current temperature. We need to get a flag showing that motion has been detected or not. And finally, we need to put the events. This is the set points saying when does the building expect to be occupied? How long are we going to wait? So when we go into the code, we're going to write a REST API. We're going to write a module that's going to do the thermal prediction. And then we're going to write a third module that does nothing but to control the temperature and look for motion. So let's go test it. We're going to use SoapUI. Once we're in SoapUI, we can go through, I've already set up various tests, and we can run through these manually. So let's hit 1. Let's run it. Let's take a look at the JSON that came back, and we got an expected value. So we'll run another one. And we got the expected value back. Now we can run through these manually one by one, but there really is a better way. And that better way is a test suite. So I've gone through and I've added all of the individual tests into a test suite, and I've added conditions for acceptance. So now we can simply run them all at once. Light is green, trap is clean. We're good to go. So in summary, what we now have is the Unit 1 Secure Transport that got an A rating from the SSL Labs. You've got a very strong foundation to build this out further, should we wish. And we have an API first architecture. So our next step, we're going to need to add the mobile UIs. Thank you for your time and consideration. Feel free to contact me.